Hi, yeah, in this video, I want to talk about how to implement directed acyclic graphs, DAGs, for causal inference in R. And this is a simple case. Okay. So directed acyclic graph DAG is a finite graph composed of nodes connected by directed edges with no cycles, meaning it's impossible to start at any node and follow a sequence of edge directions that returns to the same node. In DAGs, nodes are to be arranged in a linear order that respects the direction of edges and represents dependencies or causal relationships. Directed acyclic graphs DAGs are used in causal inference to visually represent assumptions about causal relationships, identify confounders, guide variable selection for adjustment, and clarify the pathways affecting causal effect estimation. Okay. So let me show you what all this means. First, let's generate a sample data set, random seed, sample size 500. L is a standard normal distribution. A is a linear function of L, then Y is a linear function of A and L. And here's the data frame. So here Y is the outcome, A is the exposure, and L is a potential confounder. All right. So this is a very simple case. First, you need to install dagitty and ggdag, these two packages. Okay, I already did that, so I simply load them in here. And to define the DAG, the syntax is dagitty and parentheses double quotes. Then you use DAG parentheses. Then you specify the directions. L goes to A, L goes to Y, and A goes to Y. Okay, so this defines an object. Let's call it a DAG. Okay, and then we can use ggdag to plot the DAG. And on the right hand side, you can see A from A go to Y, so exposure to outcome. And you have the potential confounder L, which go from L to A and go to from L to Y. Okay. So this is a typical diagram indicating a potential confounder of L for the causal relationship from A to Y. Okay. And the next step is important is to analyze that, is to find the adjustment sets, find the minimal adjustment sets for estimating effect of A on Y. Okay, so since here we are dealing with a very simple case, so these adjustment sets should be very simple. It's just L itself. Okay, so let's try that command. Adjustment sets and DAG exposure equal to double quotes A, outcome equal to double quotes Y. Okay, and you can see that the adjustment sets here identified as L. Okay, so when that we can just adjust L using linear regression since the Y is continuous, and we just say model. This is the model fit for LM, Y regress on A plus L, data equal to that. Okay, and then we print out the summary of the linear regression model. You can see both exposure A is very significant and the confounder L is very significant. All right, so this is a very simple and straightforward demonstration of how to implement a DAG in R. And I will do a follow-up video on more advanced options using these packages to work on DAGs. Okay. If you like this video, please like our videos and subscribe to our learning channel. Please feel free to share this video with other learners, and I really appreciate your support. Thank you.